next topic is bonding parameters. First, bond enthalpy. Amount of energy required to break 1 mole of particular type of bond into its gaseous atoms. For example, let us take, we have hydrogen molecule, okay? So there is a bond between the two atoms. So breaking of this bond leads to the formation of two hydrogen atoms. So to convert this hydrogen molecule into its gaseous atom, one bond is broken. We take it as 1 mole. So to break this 1 mole of bond, how much energy is required? That is called bond enthalpy. Got it? This is single bond between two hydrogen atoms. Okay. This bond, to break this bond, energy is required because we have to break. There is an attraction between two hydrogen atoms. Maximum attraction between two hydrogen atoms. Now we break this bond. So that means we have to move them apart to such a large distance that there is no attraction between two atoms. So to remove them from each other, energy is required because we have to work against attractive forces. To take them away from each other, what we do? We do work against the attractive forces. Okay? So that is in the form of energy. In case of polyatomic bond enthalpy, in case of polyatomic molecules, say in case of diatomic molecule it is very simple case, but if we have polyatomic molecules, let us take example of H2O. In H2O there are two OH bonds. So to break first OH, breaking of one OH bond. Okay, so let us take energy required is X1, and to break second, energy required is X2. Okay. Now, and keep in mind, H2O is also in gaseous form. OH in gaseous form. All are in gaseous form. While calculating bond enthalpy, all the molecule as well as breaking of species, when it bond breaks and species are formed, they all are in gaseous state. And when environment changes, then energy required is different. Though in both cases OH bond breaking takes place, but in this case when OH bond breaks, then there is one more OH bond. Means it is like this, OH, OH. environment is different, so energy required are different. But if question is what is bond enthalpy, then we calculate average bond enthalpy for OH bond in H2O. Here we use average, that is x1 plus x2 divided by 2. So this is the averaging of, in case of polyatomic molecules, we use average bond enthalpy. Okay, and its units are either kilojoule per mole or joule per mole. Right? Even calories can be used in case of food. Okay. So this is unit of bond enthalpy. Okay. Let us take case of methane. In case of methane, first we get CH3 gas and H gas, then CH3 gas to give CH2 gas plus H gas, then CH2 gas to give CH gas plus H gas, and at the end CH gas into C gas plus H gas. So overall it is CH4 gas to give C gas plus 4H gas. Okay, so let us take delta H. For first one is x1, for second one it is x2, for third one it is x3, for fourth one it is x4. So what is delta H for this? It is x1 plus x2 plus x3 plus x4. But to calculate average bond enthalpy for CH in CH4, that is equal to x1 plus x2 plus x3 plus x4 divided by 4, because there is a breaking of 4 CH bonds. Okay, so divided by 4 is average bond enthalpy for CH bond in CH4. We have say single bond, say double bond. Okay, it gives 2C gas, it also gives 2C gas. Delta H for this, let us take as X, and delta H for second is Y. So what is the relation between X and Y? Tell me. Is X greater than Y, X equal to Y, or X less than Y? Or any of the above? Yes, tell me. Y is greater than X, or X is less than Y, because here we have to break single bond, but in this case we have to break double bond. That means as number of bonds increases, atoms come closer to each other, and when atoms come closer, bond length decreases and bond strength increases. Relation is, say, number of bonds means bond order. Single bond means bond order is 1. Double bond order is 2. Triple bond order is 3. And Z is greater than Y, Y is greater than X. Now see, bond order is inversely proportional to bond length. Bond length means distance between the two atoms. Okay, is proportional to bond strength. So more is the number of bonds, greater is the strength of the bond. Strength means how strong the bond is. Okay, and is proportional to bond enthalpy. Because stronger is the bond, more energy is required to break the bond. Okay, this is the relation. Right? Now let us discuss the factors affecting bond enthalpy, or let us discuss bond length. It is average equilibrium distance between centers of two bonded atoms. This bond is considered as a spring. This is the average distance, right? Average equilibrium distance. Now if we compress it, these are the two atoms. When we compress it, spring goes out because there is a repulsion, and if we stretch it, it comes closer. So this is called equilibrium distance. Equilibrium means when potential energy is minimum. In spring, if we stretch it, there is an increase in potential energy. If we compress it, again there is an increase in potential energy. Okay? So this is the distance between the two atoms, that is called average equilibrium distance between centers of two bonded atoms. That is called bond length. And bond length is determined by X-ray diffraction. Bond length is measured by X-ray diffraction. Bond length is measured by X-ray diffraction. So factors affecting bond length. And bond length is measured in picometer, nanometer, centimeter, angstrom. Okay? So factors affecting bond length. First is size of atoms. Yes, tell me, what is the effect of size? If size of the atom is large, then what is the relation with the bond length? See, if atoms are small, atoms are large, what happened? If atoms are small, bond length is smaller. If atoms are large, bond length is large. So bond length is directly linked to the size of atom. Now tell me, out of chlorine and bromine, which one is larger in size? Chlorine, bromine, iodine. As we go down the group, size increases. So bromine is larger than. So for example, as bromine is larger than that of chlorine, bond length HBr is greater than HCl, right? Because bromine is larger than chlorine, so HBr is, bond length of HBr is more than that of HCl. Now, second, multiplicity of the bond. Second factor. Multiplicity of bond. Tell me, what is the relation with the multiplicity of the bond? Multiplicity means multiple bonds between two atoms. Double, triple. So as number of bonds between two atoms increases, multiplicity increases. As multiplicity of the bond increases, atoms come close to each other, so bond length decreases. Okay, for example, bond length of say triple bond C is less than double bond, which is less than single bond. So for triple bond it is 120 picometer, for double bond it is 134 picometer, and for single bond it is 154 picometer. Okay, multiplicity of the bond is bond order. Simple. Bond order increases, bond length decreases. Okay, now third point. Type of hybridization. So tell me, SPDF. Out of SPDF, which one is closest to the nucleus? Keep in mind, bond length is also associated with type of hybridization. Hybridization means mixing of orbitals. Okay, so as S character increases, bond length decreases, because S orbital is smaller than that of p orbital, or we can say S orbital is closest to the nucleus. Okay, can we write? Yes, we can write here. So say if there is CH bond with sp3 hybridization, means 1s and 3p, or CH bond, the carbon is sp2 hybridized, and third is CH bond sp hybridized. So tell me, in sp3, what is the percentage of s character? Say, how do we calculate? Percentage of s character is equal to number of s orbital over total into 100. See, total orbitals are 1s and 3p. Total are 4. And out of 4, 1 is s. So 1 upon 4 into 100. So it is 25%. sp2. What is the percentage of s character? sp2, 1s and total 3. So it is 33.3%, or we can say 33.33%. Good, Sakshi, Namita, Ralam, Abhay. What about the others? Now understood? How do we calculate? Even if you don't know earlier, it is simple. SP means 1S, 1P. Total 2. Out of 2, 1 is S. So 50%. sp3 is largest because percentage of s character is minimum. More is the s character, smaller is the bond length. This is largest. Bond length. Can I write here? So bond length of CH is greater than for sp2 and then sp. This is 111 picometer, this is 110 picometer, and it is 108 picometer. There are 3 factors. First, size of the atom, larger size, large bond length, smaller size, small bond length. Multiplicity of the bond, more is the number of bonds between 2 atoms. They are closest to each other, so bond length is smallest. Okay, and third is hybridization. More is the s character, smaller is the bond length. Bond angle. It is the angle between the bond pairs. Angle between bond pairs. Angle between bond pairs. For example, in CO2, there are 2 bond pairs. It lies like this. So angle between the 2 bonds is 180 degree. So angle between bond pairs is called bond angle. In BF3, boron, it is like this. So angle is 120 degree. Methane, it is non-planar and angle is 109 degree 28 minute. 109 degree 28 minute. And NH3, see, actually angle is between the bonds. Here they are repelled, so the bonds are closer to each other. So angle is 107 degree. In water, they are further closest, and angle is 104.5 degree. Means as lone pair increases, say total electron pairs 4. Total electron pairs 4. Total electron pairs 4. But because electron pair repel each other because of like charge. In electron pairs, electrons are negatively charged. So negative charges means like charges repel each other. But lone pairs repel more than bond pairs. So this is the relation. Lone pair repulsion is greater than lone pair bond pair repulsion, which in turn greater than bond pair repulsion. Right? Because lone pairs occupy large surface area. Coordinate bond or dative bond. Coordinate bond or dative bond. I have given some idea about that. Actually, coordinate bond, once it is formed, it is just like covalent bond. There is sharing of electrons. Like in covalent bond, what would happen? Like hydrogen has one electron, each hydrogen has one electron. So they will share these two electrons. Okay, one electron each will contribute, and therefore there is a formation of covalent bond where 50% share is of first hydrogen and 50% share is of the other hydrogen. Like covalent bond. I am talking about covalent bond. In nitrogen, like nitrogen has 5 valence electrons. So each nitrogen contribute 3 electrons. Each nitrogen contribute 3 electrons to share with each other, and therefore there is a formation of 3 covalent bonds between 2 nitrogen atoms. So in covalent bonds, 50% share is of each atom, 50-50. Both will contribute equally. When sharing takes place, for the sharing, both contribute equally. But in coordinate bond, see the case of coordinate bond. In coordinate bond, like we have ammonia. This is ammonia. Ammonia has 3 covalent bonds and 1 unshared electron pair, because nitrogen has total 5 electrons. Out of 5, 3 are shared with hydrogens and 1 electron pair left unshared, that is called lone pair. Now when it comes in contact with BF3, in BF3, see, in BF3, boron has 3 valence electrons. All the 3 are shared with each fluorine, 3 fluorines. Now, how many electrons it has? 6 in its valence shell. Ammonia, 8, complete. But if ammonia share its electron pair with boron, then both have octet of electrons like this. But in this sharing, total share is provided by ammonia. Total share is provided by ammonia, and it is denoted like this arrow, and this arrow is from the one which donate the pair and towards the atom which accept the pair. So here nitrogen is donor and boron is acceptor. So that is why it is also called dative bond. There is donation of the pair for sharing, and that shared pair comes from the same atom. In covalent bond, there is 50-50% share, but here 100% share is from the single atom, okay, and that will share with other atom which is deficient of electron. So such a molecule having unshared pair and complete octet, that is called electron rich molecule, and one which has less than 8 electrons, that is called electron deficient molecule, and such a bond is called dative bond or coordinate bond. Now say in H3O plus, you know, water is like this, okay, and H plus has no electron. So when H plus is attached to it, it is like this. NH4 plus. In NH4 plus, you know, again same case, ammonia has a lone pair, H plus has no electron. So this is called ammonium ion, this is called hydronium ion. Hydronium ion, and this is ammonium ion. So there is a formation of this type of bond. So this arrow indicates that there is a bond formation between H and N, and shared pair comes from nitrogen only. Okay, second thing, say if we don't want to represent it by this coordinate bond, then we just write simple this bond, and this gets positive and boron gets negative. So this is also one of the representation of coordinate bond. Either you make an arrow or positive and negative. Positive to the donor and negative to the acceptor. Okay. So in this case, if we remove it by this type of bond, then H is, because H gets negative, already it has positive, so it is neutral, and this gets positive. Right? Here, if we remove it by this, it gets neutral, means negative, already positive, so it is neutral, and this gets positive. Like that. Or simply you can write it as NHHH whole positive.